Okay, solving motion problems. How does an object's speed affect the distance it travels in time? Speed is the rate at which distance is traveled. Therefore, a faster object travels a greater distance than does a slower object in the same amount of time. Objects often change speeds over time, traveling faster at certain moments in time and slower at others. It is often useful to know an object's average speed. In equation form, the average speed of an object is the distance traveled divided by the time. So here, speed is distance over time, just like it says here. The units for speed and velocity are meters per second. Sometimes we see them as miles per hour, but it's conventional in physics to use meters per second unless otherwise indicated. The speed or velocity of an object at a particular moment in time is known as the instantaneous speed or instantaneous velocity, respectively. Right? Velocity if you know the direction, and speed if you don't. The term used to describe a speed or velocity that does not vary over time is constant speed or constant velocity. Right? So constant speed without direction, constant velocity with direction. Instantaneous, if at that instant it's going that speed or velocity. When an object travels at constant speed, then its average speed is equal to the constant speed, and its instantaneous speed is the same at every moment in time. So that's sort of the trivial case. When something is moving at a constant speed, then the average is obviously equal to that constant speed, and it's the same. The instantaneous speed is the same every instant. Velocity is an object's speed as well as the direction in which it is moving. 24 meters per second west is a velocity. 24 meters per second would be a speed. An object moving at constant speed, therefore, may not be moving at constant velocity if the direction of motion is changing. Something moving at a constant speed but in a circle would have a changing velocity, right? Because the direction would be changing even though the speed is not. The equation for speed can be rearranged to find distance or time. This would be the arrangement for distance. This would be the arrangement for time. You can also use the visual calculator. So if I cover up the d, I'm left with s times t. If I cover up the t, I'm left with d over s. And if I cover up the s, I'm left with d over t. Okay, so that's a way to check your work, but please, it is no substitute for algebra. How can position, velocity, and acceleration be used to describe the motion of an object? An object's position, velocity, and acceleration need to be known fully. To describe the object's motion, there are relationships between all three quantities that are described by the basic equations of motion. The displacement or change in position of an object is a vector that can be found by subtracting the initial position from the final position. The distance an object has traveled is a scalar and is equal to the sum of all the individual movements of an object regardless of the direction of those movements. Let's do an example here to illustrate the difference between distance and displacement. So if you walk a mile to school in the morning and a mile home in the afternoon, your distance would be 2 miles, but your displacement would be 0. So say if you're considering the displacement to school +1, then the opposite direction going home in the afternoon would be -1 mile. So 1 plus -1 would be a total of 0 displacement for your travels for the day. If an object has changed direction during its motion, then the distance traveled and the displacement will be different. The average speed of an object is a scalar and is equal to the distance traveled divided by the time. The average velocity of an object is a vector and is equal to the displacement divided by the time. Okay, so another reason why speed and velocity are two different things. Instantaneous velocity is a vector that represents the velocity of an object at a particular moment in time, a snapshot, if you will. Acceleration is the rate at which the velocity changes. Acceleration, by the way, is always a vector. There is no scalar analog for acceleration. The average acceleration of an object is equal to the change in velocity, the final velocity minus the initial velocity divided by the amount of time during which that change took place. Acceleration is a vector quantity. Acceleration is always a vector quantity. How can motion be graphically represented? Motion can be represented graphically with position versus time, velocity versus time, acceleration versus time graphs. Each graph tells us something important about the object's motion. There are relationships between the object's position, velocity, and acceleration which can be determined by analyzing the graphs. I'm going to hold you guys responsible, and I'm just going to go down here, get some room, and illustrate a problem. So if I have a car that accelerates from 0 to 100 meters per second in 5 seconds, right? So this is velocity versus time. Could I find the acceleration, and could I find the total distance the car's traveled? Well, the distance is actually the area underneath this graph, right? And since this is a triangle, well, it means the distance is going to be 1/2 base times height. You remember the area of a triangle. So 1/2 times 5 seconds times the height, which is 100 meters per second. Our seconds cancel out, leaving us with the answer in meters. 100 times 5 is 500. Half of that is 250 meters. So in starting from 0 and accelerating to 100 meters per second, the car travels a displacement of 250 meters. Now the acceleration. Well, the acceleration is the rate of change in the velocity. A rate of change has a name in math class, and it's called the slope. So the acceleration is equal to the change in the velocity, so v final minus v initial over the elapsed time. And that's going to be, well, v initial is just 0, so I'm going to say it's 100 meters per second over 5 seconds is going to be 20 meters per second squared. Okay, so just from knowing the graph and the initial and final velocity, we were able to find both a displacement or distance traveled and also the acceleration, the rate of increase in the velocity. And if you look, we go from 0 to 20 meters per second in 1 second, 0 to 40 meters per second in 2 seconds, 0 to 60 meters per second in 3 seconds, 0 to 80 meters per second in 4 seconds, and of course 0 to 100 meters per second in 5 seconds. Okay, so the acceleration is just the rate of increase in the velocity for every second that passes. Okay, I hope that helped. Objects in the air known as projectiles follow a parabolic path known as a trajectory. This motion of a projectile is referred to as projectile motion, strangely enough. So when we did the Shoot the Monkey gizmo, what we were doing that, okay, and the reason for the parabolic path is because we have accelerated motion in the vertical direction and constant speed motion in the horizontal direction. So projectiles have a constant velocity in the horizontal direction since no net force acts on the projectile in the horizontal direction. Projectiles accelerate downward in a vertical direction due to the force of gravity, otherwise known as the weight. The combination of constant velocity horizontally and acceleration in the vertical direction leads to the curved parabolic path of the projectile. The horizontal and vertical motion components of a projectile's motion are independent of each other. We saw that in the Shoot the Monkey gizmo, because as long as we were aiming directly at the monkey when the banana was fired and when the, simultaneous with the monkey falling, the monkey was able to catch the banana because they both fell at the same rate. The equations of motion for a projectile are as follows, written really small under here. Okay, get out your microscope. So x is the velocity in x times time. The velocity in x, since it's horizontal, is the same throughout. Okay, it doesn't change. For us, with the monkey, there was no initial velocity either up or down because the monkey dropped out of the tree. It wasn't thrown down, it wasn't thrown upward. So y is 1/2 gt squared, where g is the acceleration due to gravity. Okay, and with those two things we could figure out everything about the monkey falling, and we could also figure out what was going on with the horizontal translation of the banana. Okay, g is of course the acceleration due to gravity, negative because it's down. If you guys want to use -10, that's fine. I don't care. Most of the time it'll get you close enough to the answers so that you can make a decision on a multiple choice test. And if you're just doing a problem, -10 is close enough for me. How can motion sensors be used to record and describe the motion of an object? Motion sensors use technologies such as ultrasonic sound waves, a kind of sonar, to determine the position over time. Electronic motion sensors can generally record position and time data more accurately than a person using a stopwatch or other manual means. Photo gates detect when an object passes through a certain point. How does friction affect the motion of an object? Friction is a resistive force that comes in two forms, static and kinetic. Usually the static friction is when an object is not moving relative to a surface and it's a little higher. Kinetic friction is typically when the surfaces are moving relative to each other and is a little bit lower than static friction. Friction acting on objects at rest is known as static friction. Friction acting on objects in motion is known as kinetic friction. Friction acts in the opposite direction as the motion of a moving object, and in the opposite direction as the push or pull on a stationary object. Friction can occur between objects in any combination of states. Yes, even New Jersey. Just kidding. When friction occurs between a solid and a gas, or between a solid and a liquid, it is sometimes referred to as drag. Friction can occur between a solid and a gas. Just stick your arm out the window at highway speed, and the force of the air hitting your arm will bounce, the air molecules will bounce off your arm, pushing it backward. Okay, I hope that makes things clearer.